This reference guide is the second reference guide of the 6th unit, and it deals with parallel and perpendicular lines. At the top of the reference guide, you'll notice there are 5 definitions. Each of these definitions is pivotal when trying to understand the questions that correspond to them. So let's go through the definitions, and then we'll look at some problems together. So the first definition is negative reciprocal. Now, you may have heard the term reciprocal in the past, and it's likely that you were taught that to mean a flipped fraction, which is true. A negative reciprocal is a flipped fraction with the opposing sign to which you started with. So, for example, we can look at a few examples of negative reciprocals. So let's say we started with the number 2 over 5, or the value 2 over 5. And we wanted to determine its negative reciprocal. Well, we start just by flipping the fraction. So it becomes 5 over 2. Since we started with a positive value, its negative reciprocal will be negative. Let's look at another example. Let's say we were looking at the number 4. Well, if we wanted the negative reciprocal of 4, we need to flip 4. Well, 4 typically isn't written as a fraction, but it can be expressed as 4 over 1. So when we flip that, we get 1 over 4. And again, we started with a positive value, so its negative reciprocal will be negative 1/4. Well, what happens if we start with a negative? Let's say we start with negative 3 over 7. We want the negative reciprocal of that. Well, we just start, as we did before, by flipping the fraction. And now you'll notice we started with negative 3 over 7. So since we started with a negative, its negative reciprocal will be positive. Okay? So when taking negative reciprocals, we flip the fraction and we change the sign. Parallel lines is a term that you've certainly heard before. You were likely taught it to mean lines that never meet. And that is true. They are lines that never meet because they have identical slopes. And that is the important word here. Identical means exactly the same, both in value and in sign. Perpendicular lines, this is where we'll see the term negative reciprocal, and we'll understand why it's important to fully understand that term. Perpendicular lines are 2 lines whose slopes are negative reciprocals of one another. So if you have a line with a slope of 3/7 and a line with a slope of negative 7/3, they would be negative reciprocals of one another. It may be worthwhile to note that if the slopes are negative reciprocals of one another, they'll meet at 90-degree angles. And you've seen that before with perpendicular lines, like an example of perpendicular lines being a horizontal and vertical line. We know they meet at a 90-degree angle, as does any pair of perpendicular lines. Now the last 2 definitions are shapes. And you've seen shapes before. You know what these shapes are. But we'll be doing some work that incorporates slope in helping us to determine which of these shapes a 4-sided figure could be. So parallelogram is your first definition. It is a 4-sided figure with parallel opposing sides. And that's it. That's the criteria that needs to be met for something to be a parallelogram. So the top must be parallel with the bottom. The right must be parallel with the left. Now, when we look at the definition for rectangle, we'll see a very similar start. In fact, the first 8 words are exactly the same. A 4-sided figure with parallel opposing sides. But now there's additional criteria that must be met in order for something to be a rectangle. The opposing sides must meet at 90-degree angles, which must mean, if we bring this back to where we started, that the opposing sides must be negative reciprocals of one another. Okay, so a parallelogram, 4-sided figure with parallel opposing sides, top, bottom, right, left, they are all parallel. The top is parallel to the bottom, the right is parallel to the left, I should say. And a rectangle, that idea, but anytime that you have lines that meet, they meet at 90-degree angles, or they are negative reciprocals of one another. All right, so let's look at some sample problems. And the first one has been done for you, but we'll just quickly talk about this problem as well. So line GH passes through the point G at negative 4, 2, H at 2, negative 1. Remember that when you're writing coordinates, X always gets written first, Y always gets written second. So when we look at the coordinate G, it's at negative 4 on the x-axis and 2 on the y-axis. Line JK passes through J, which is at negative 1, 7, and K, which is at 7, 3. And then we have a third line kind of in the middle of the two, which is line MN. It passes through M at negative 4, 5, and N, which is at 5, 1. So we're asked to sketch the lines. Well, that's been done for you. You can see in the diagram that the lines are there and they are properly plotted. And we're asked if they're parallel or not. Well, it's important when we do this, as always with math, we have to justify our answer. So it's important to show all of your work. And where this becomes especially important in problems like this is if you just use the eyeball test, maybe they all look parallel. Maybe none of them look parallel. Maybe two of them look parallel and one doesn't. But if we look at the diagram, it's impossible to say exactly which two, if any, are parallel, or if all three are parallel to one another. So to do this, we have to work out the slope. And we have worked out the slope countless times using our formula y2 minus y1 over x2 minus x1. All right, we have done this a bunch in Unit 5, and we did it in the first reference guide for Unit 6. So I won't redo the work that's on the reference guide in front of you, but instead we'll just talk about what we see. So when we find line GH, we'll notice that when we subtract our y's and subtract our x's, we get a rise over run of negative 3 over 6, or down 3 to the right 6. Now what you'll see is the fraction has been reduced. Again, this is something we've talked about, and it's very important to make sure you reduce your fractions. We'll talk more about that in a second. When we look at line JK and we subtract our y's and put them over the difference in our x's, we get negative 4 over 8. Which again, it's very, very important, as I'm showing with the stars here, to reduce that fraction. And here's where we can see why it's important. If we don't reduce GH, we get a slope of negative 3 over 6. If we don't reduce JK, we get a slope of negative 4 over 8. And if you're rushing, or if you're just not paying enough attention, you may say that those are different slopes. They're different numbers. There's a different numerator for each and a different denominator for each. So you may say the slopes are not the same, and you may be left to conclude that the lines are not parallel. However, once you reduce them, as you should always reduce fractions, you can see that they are both negative 1/2, which means the slopes are the same. So make sure you reduce your fractions. It is one of the golden rules in math. Okay, so we can determine that G and H and JK, or GH and JK are parallel. Now let's take a look at MN. When we take a look at MN, we get negative 4 over 9. Now this is really, really close to being negative 1/2. It's almost there, but it's not quite. Since it's not exactly negative 1/2, it is not parallel with the other two lines. If you stretch this over a big enough plane, it will eventually touch the other lines. So we would conclude then, as you can see here, that GH and JK have the same slope. So that means that they are parallel. And MN is not parallel to either line. MN has a different slope, so it's not parallel. And that's all there is to that first type of problem. That is a common style of question. You'll be asked to plot some lines or determine some slopes and indicate if the lines are parallel or not. And we'll actually see a slight variation to that in one of the practice problems we're going to do later. Okay? The second problem that's done for you is a little bit faster to work through. And it's along the same lines as what we just did, but you have to put a different spin on it. You have to really know what your terms are to answer this one. So let's read it. Question 2, we're going to indicate if the slope of a line that is, we're going to indicate the slope of a line that is perpendicular to a line that passes through the points 4, 2 and 7, 4. So again, the wording here is a little bit maybe confusing, but we want to find the slope of a line that's perpendicular to a line that's given. So in order to figure out a perpendicular slope, we have to find the slope of the line that's given. So if we know the points 4, 2 and 7, 4, well, as we've done before, we'll assign 1 x2, y2 and one x1, y1. So I'll call my first one my x1, y1, or my first point. I'll call 7, 4 my second point. And then we're just subtracting. So my y2 minus y1, well, y2 is 4, y1 is 2, and then we divide that by 7 over 4, so we get a slope of 2/3, m equals 2 over 3. So we know that the slope of the line whose points are given is 2/3. We are asked to find the slope of a line that's perpendicular to that. Well, if you remember from the definitions on the front of the page, lines that are perpendicular have slopes that are negative reciprocals. So all we're doing is we're saying, what is the negative reciprocal of 2/3? Well, we flip our fraction, we change our sign, and we get negative 3 over 2. Okay? So with a question like that, you can find the slope of the line whose points are given, and then it's up to you to understand that perpendicular means negative reciprocal. So now we'll move into the 2 practice problems which haven't been done for you. And I mentioned earlier that there is a slight variation to the question that's on the front, and this is it. This is a very common style of question, whether it be on worksheets in the textbook, maybe even a type of question you see on an assignment or a probe or a test, something like that. It reads, line PQ passes through the points P, which is at negative 7, 2, and Q, which is at negative 2, 10, and line RS passes through R, which is at negative 3, negative 4, and S, which is at 5, 1. And we're asked to determine if the lines are parallel, perpendicular, or neither, and show how we know. Well, let's recap how we would know if they're parallel. The slopes would have to be identical in sign and in value. If they're perpendicular, well, the slopes would have to be negative reciprocals of one another. And if it's anything but that, if it's anything but being identical or negative reciprocals, then it would be neither. So let's start with line PQ. And we need to find its slope. So the slope, of course, is y2 minus y1 over x2 minus x1. So we'll go 10 subtract 2 over negative 2 subtract negative 7. 10 subtract 2, of course, is 8. Negative 2 plus 7 is going to be 5. So we get a slope of 8 over 5 for line PQ. Line RS, meanwhile, again, we take the difference in our y values. So in this case, it's going to be 1 subtract negative 4 over 5 subtract negative 3. And here we get 5 over 8. 1 plus 4 over 5 plus 3. Now these lines are reciprocals of one another, but they are not negative reciprocals of one another. So you have to be really careful with some of the answers you get. Since they're not negative reciprocals, we would state that they are neither. So therefore, remember, with negative reciprocals, the signs have to be different. So the lines are neither parallel nor perpendicular. Okay? And it's a good example to put early on because it makes you remember just how important the details are. 5 over 8 and 8 over 5, they are reciprocals. Since they're not negative reciprocals, we would indicate that they are not parallel nor are they perpendicular. They are neither. The second one, this is where those definitions of shapes from earlier comes into play. A quadrilateral is a shape with 4 sides. Determine, showing your work, whether the quadrilateral below is a parallelogram or a rectangle. We talked before about the criteria to be either of those things. If it's a parallelogram or a rectangle, the top will be parallel to the bottom. So EH will be parallel to FG. Also, the left side, EF, will be parallel to the right side, GH. That will make it a parallelogram or a rectangle. In order for it to be a rectangle, however, where any of those corners meet has to be a 90-degree angle, which means the sides must be negative reciprocals of one another. So what we need to do, the first thing we have to do, is find the slope of EH. So we know how to find slope, y2 minus y1 over x2 minus x1. But before we can do that, we need our coordinates here. So E is at negative 1, comma 3. H is at 2, comma 2. G is at 0, comma negative 3. And F is at negative 3, comma negative 2. Okay, so you have to be able to pull appropriate coordinates out if you want to be able to do these questions. And we've done that. So now we look at EH. And it doesn't matter which we call y1 or which we call y2. I'll go right to left. So we'll go 2 subtract 3 over 2 subtract negative 1. And we get a slope of negative 1/3. We can check that by looking at our diagram. And if we start at E and go down 1 to the right 3, we should get to H. And we can see that we do. So now let's look at FG. Well, if this is a parallelogram or a rectangle, EH has to be parallel to FG. If it's not, well then we're done the problem. It would be neither a parallelogram nor a rectangle. So we'll go negative 3 subtract negative 2 over 0 subtract negative 3. And we get negative 1 over 3. So the first bit of criteria has been met. The top is parallel to the bottom. Now we're going to need to take a look at the left and the right. And I'm going to start on the left. So we'll go negative 2 subtract 3 over negative 3 subtract negative 1. And here we get a slope of negative 5 over negative 2, which gives us, I have to go down here a little bit, 5 over 2. Remember that a negative numerator and a negative denominator both become positive. So now for GH, again, if this is a parallelogram or a rectangle, left and right sides have to be equal to one another, or have to be parallel to one another, sorry. So let's take a look and make sure that that's the case. Negative 3 subtract 2 over 0 subtract 2. And we get a slope of negative 5 over negative 2 again, which is 5 over 2. So we have found that the left side is parallel to the right side, the top is parallel to the bottom. So we are almost done this question. We know that it's either a parallelogram or a rectangle, but we don't know which it is. So in order to figure out which it is, look at a corner. And it doesn't matter which corner you choose, I'm just going to pick that one. That is where EH meets EF. So we look at the slope of EH, we look at the slope of EF. If those slopes are negative reciprocals, then it's a rectangle because the corners are 90-degree angles. If it's anything but a negative reciprocal, then it's not a rectangle, it's a parallelogram. And we look and see negative 1/3 and 5 over 2, those aren't negative reciprocals of one another. So we would say, therefore, the shape is a parallelogram. Okay, and so this just demonstrates some of the properties of slope and how you can make determinations of shapes or of lines simply by determining the slopes of some of its parts.